why don't we get started? It's great to see so many of you on these little screens. For those of you who don't know me, I'm Professor Bob Delaney. I'm the Director of Undergraduate Studies for the physics major, and I'd like to welcome you all to this virtual gathering in which for us to celebrate the Hopkins physics class of 2020. It's it's a really an outstanding group of students who are graduating this year. Personally, I'm pleased to have gotten to know, I think, all of the graduates, either as students in the advanced lab course or as an advisee. And I think I could dare risk say that this is probably the best class of physics majors we have ever graduated. You'll meet someone in a few minutes who might want to debate that, but I stand by that statement. And to those of you who are graduating, I just want to take the opportunity to thank you all for the many contributions you've made over the past 4 years to the department, both in terms of your efforts in the classroom and in research, both in Bloomberg and I know in some cases across campus, and more generally in helping to make such a vibrant and welcoming community in the department and in Bloomberg. You're really an exceptional group of students, and you're graduating at an exceptional time in history. If it were an ordinary year, we would all be gathering in person this afternoon for a reception in Bloomberg the afternoon before commencement, and obviously we can't do that this year. And so what we've decided to do is do something even better, right? And that's meet virtually, and we have to make it even better, we have invited one of your predecessors, really a forefather, if you can think about it, Mr. Paul Gosling, who graduated a number of years ago from the department, and he's kindly agreed to speak to us today and tell us a little about his experiences since graduating. And I'll say more about introducing Paul in a minute. But first, I'd like to turn it over briefly to Professor Tim Hackman, the chair of the department, who would like to, I think, say a few words. So, Tim.
Great, thank you, Bob. Yeah, so as the chair, I have many duties, but this is always one of the ones that I enjoy the most every year. And I'm sorry we can't be here to celebrate in person, but as Bob said, we're together in spirit, if not in physical form. I wanted to echo what Bob said, just to congratulate you on the accomplishments that you've had, in the classroom and the research projects you've done. And as Bob said, I think just the overall contribution to the intellectual and social life of the department has really been exemplary. You've all learned to think like a physicist, we hope, and I think that will serve you well in your life's journey, no matter where that takes you. Of course, we're going to follow your career path with great interest, and we want you to please stay in touch with us so you can remain part of our extended family. It's really important that we maintain communication with our alums. Case in point will be our speaker today. I wanted to give a special shout out. Normally we can present these medals in person. Again, we're going to have to do it online, but I wanted to congratulate the co-winners of our Curve medals this year, Sydney Timmerman and Catherine Zhang. This is an award given every year for outstanding performance in the classroom and research and as a citizen of the department. So congratulations. And finally, before I end, I just wanted to personally thank Bob and Kelly for organizing this event under trying circumstances, and more generally just for the important role that they've played over the last few years in making your journey through the department hopefully as happy and productive as it has been. So with that, congratulations again, and on with the program.
Okay, thanks, Tim. So great. So now, I'm sure many of you are very excited about graduating tomorrow and looking forward to the next adventures in your life that await you. Some of you might be looking at the future with a bit of trepidation, understandably, but I'm sure that will be short-lived. But there's one thing I want you to keep in mind going forward, and that is that graduating is really a very unique and special event in your life. You know, there are many things that can change and probably will change as you go forward in life. You know, you can change where you live. If you want, you can change the color of your hair. Some of you, it will change whether you even have hair. But the one thing that's never going to change after tomorrow is that you'll always be an alumnus or an alumna of Johns Hopkins University, and you'll always have a home in Bloomberg, in the Department of Physics and Astronomy at Hopkins. And I hope you all remember that. Keep that in mind. With that sentiment in mind, maybe someday, decades from now, you'll be called upon by a name you vaguely remember to called in for old time's sake. And that is with that in mind, I'd like to introduce our next speaker, who is Mr. Paul Gosling. Now, you know, a minute ago when I said that your class, the class of 2020, is surely the best physics class Hopkins has ever seen. I think the consensus prior to this year was that certainly the best class of physics majors we've ever had at Hopkins was the class of 2003. And that's of course the class, the year in which Paul graduated. Paul made quite an impression as a student at Hopkins, not only academically, but in terms of just the other contributions he brought to the department and then to the university. His active role in the Society of Physics students and actually in helping to found an outreach effort that connected the department with the local Baltimore community. These are things I remember well. Now, another thing Paul was involved in when he was at Hopkins was in research, not actually in the department primarily, but over in the engineering school. If I remember correctly, the science that was the topic of the research involved fluid dynamics, I think, in microgravity conditions. And so as part of the experiments, Paul conducted his research on an aircraft that's known colloquially as the Vomit Comet. Basically, this is an airplane that they take to very high elevation and then plunge straight downwards, accelerating at exactly or as close as they can to G, so that the conditions inside the aircraft mimic those of microgravity. And then they do this over and over again. And so each plunge, you get a few minutes of data acquisition on your experiment. And so Paul bravely took his experiments onto this aircraft as a student. I remember this well. He was green for several weeks afterwards, and so most people who would have this kind of experience would probably want to get as far away from that kind of work as possible. But clearly Paul was hooked. After graduating, he basically pursued a career in aerospace engineering. First with a series of internships at Goddard Space Center, Lawrence Berkeley Labs, Ames, NASA. And then began his career where he currently is at Johnson Space Center in Houston. Paul's current position at Johnson Space Center is he directs the research program in what's known as environmental design. So this is basically designing the systems that provide oxygen and water and basically life support, as I understand it as an outsider, for all manned spacecraft, so human occupied spacecraft. So basically, as I understand it, Paul's job now is to make sure the astronauts stay alive, which sounds like a pretty big responsibility. But anyway, we're very pleased to have Paul with us today, virtually from his home outside of Houston, to tell us a little bit about his first. I think you'll find out what he's going to tell us about, but I think a little bit about his time at Hopkins and then the journey he's been on since then, which I hope you'll all find interesting and inspiring as you step forth. So Paul, take it away whenever you're ready.
Okay, well, that's very humbling. Thank you so much for the introduction, and thanks to the department for inviting me today. It's really nice to see some friendly faces. I'm not sure if I'm able to see everybody on the video. See Professor Schwartz there, who I spent a lot of time with. Very good to see you. Professor Reich, thank you for attending today as well, and everybody else who helped contribute to my growth while I was there. It was a very special place for me, so I'm really honored to be able to be asked to be here today. So first of all, congratulations to the graduates. This is a day you've worked very hard for. I know the current circumstances are presenting some challenges, especially for those who'd been looking forward to sharing this event in person, but rest assured, this is a moment that will always be remembered, almost maybe even more so because of the way we're doing it today. I, for one, am thankful that it led to me being able to meet with you today. This university and this department is a special place to me. It's been 17 years since I was in your shoes, but in some ways it kind of feels like yesterday. I'll touch briefly on some of my experiences in the department and my path since then, but my main purpose today is to talk about your path. I can only guess what may have changed about the JSU physics experience and what has stayed the same. I'm guessing there are more iPhones now since they hadn't been invented yet when I was there. I do remember some things that may sound familiar, like hitting a wall, reading a textbook on waves, and turning it over to the cover and finding the author's name was literally Pain. That was a clear memory in my mind. Opening textbooks and reading sentences like, "It should be intuitively obvious to the most casual observer that," and followed by something that was not intuitively obvious to me. Clearly remember the Society of Physics students, meetings, talks, and trips, and helping to organize those. Working on projects in Bloomberg, from the machine shop in the basement to the telescope on the roof, roaming around looking for pizza. Definitely remember overnighters in the Puck lab trying to figure out how to do Lorentz transforms on Maxwell's equations. And I remember the debates and the aha moments with the great people there, trying to figure out, is the wave function materially real, or is that just a math model that predicts its interactions, or does it matter? Those kind of things. You know, I remember a heated discussion about a partial differential equation that I was having trouble with. This example is not going to make me sound very good at math, but I was sort of forcefully saying, you know, but I took the derivative. And my interlocutor, I think it might have been Professor Bagger, said, with respect to what? And I said, oh. And that was this moment I could literally feel the synapses clicking into place. And I finally got it, that they were decoupled. And the reason I give that example, even though it makes me look not very good at math, is because I use it later. I refer to it later here when I talk about decoupling challenges and addressing them individually. So, but even after all that and the foundation you've built here, I remember finding that there could be almost so many possibilities after graduation that it may be hard to even see them all. I know that was the case for me. You know, graduates from here have gone on to countless fields. And some of you may have already found your next step. Some of you may still be working on it. And that was me. I was the one still working on it. So thank you for the introduction, talking about, you know, the internships I did. I won't necessarily get into these in detail unless it's of interest. And we can touch on it in the Q&A. The point for me was to get experiences, get a variety of experiences in different fields. And that's something you can continue to do from here forward. What wasn't mentioned was my promising career as a photocopier at Kinko's Copies back when they had those. And I still, to this day, I can't really watch somebody do photocopies not because I'm scarred from the experience, but because I have this intense need to critique them on their style and method. But, you know, I tried out a lot of different things. You know, at Lawrence Berkeley, I actually started as a dishwasher. It's one of those things where you just got to start with what you got, and then I worked my way up to do research there. At Ames, I started as a typist, same thing, you know, so just start with what you got, work your way up. I had a spectacular failure. I tried to intern at the San Francisco General Hospital emergency room and volunteer there and help out here and there. I was told after a little while that my services were no longer required there. I wasn't good at it. And so, you know, when you get different experiences, you figure out what you're good at, what you're not, what you enjoy doing. And that's kind of the real benefit of it. So, and that's something you can do really all throughout your career. So at that time, I didn't know exactly what paths were going to lead somewhere. I kind of think of the path I took as like one run in a Monte Carlo simulation of possible paths you could take from Hopkins, as a forward career. Not sure if that's a very useful thought experiment, but another way to think of it is like a tree with, you try to branch out in new ways. Occasionally you'll find you get some sunlight, you can keep that branch going. Occasionally you'll find there's not enough there and you need to redirect some resources and try another branch. I remember the big crossroads for me graduating from Hopkins was continuing in academia versus going to industry. That was my big sort of thing I was grappling with. Some of you may be grappling with similar things. Nothing I say here today is going to help you decide any of that, but I do hope to give you some observations I've picked up over time that may help you succeed no matter what path you take. So as was mentioned, I started at NASA Johnson Space Center after graduating as a flight controller in the Mission Control Center at Johnson Space Center, and focusing on International Space Station thermal and power systems. And I can give an example later of what that looked like. By the way, the training manuals here weren't much better. I opened the first one and there was a sentence in it that read, the EETCS, PVTCS, PFCS, ORU is an IORT to the PVCU, MDM, CSCI, period. That was the sentence in the book. And I raised my hand and said, check please. I'm not really sure if I'm ever going to be able to understand this or get this. It turned out it was just a different language. It was just a lot of acronyms that, folks had gotten used to using them, and it just kind of became second nature. That may apply really in any field you go into. You show up and they're kind of speaking their own language. Just give it some time and you'll get used to it. I understand what that sentence means now. I've since edited the volume to add that should be intuitively obvious to even the most casual observer. The point is not the details of my career, but again, if we want to touch on it at the end, I can give an example of one of the times I was in kind of a hairy situation in mission control. So from then I went and did some time in the, makes it sound funny, spent some time in the Office of Legislative Affairs at JSC. So kind of working on how we interact with the Congress and how that works. And so I've got some interesting insights on that if anybody's interested in like agency interaction with Congress and all that. And then I came back and served as the group lead for ISS thermal and power systems, learned a little bit about leading through change. The job became very quickly non-technical, which is something I'll talk about here in a bit too. So it wasn't long before I wasn't doing calculations anymore. It became almost more like working with people became the more dominant effect. And then worked on some Orion vehicle integration, kind of systems engineering for the Orion vehicle that's going to be launching here next year to go back to the moon. And then currently serving as environmental systems branch chief. And our focus is flight operations. So we have the flight controllers that are operating the International Space Station environmental systems. And then we're also working on the ops aspect of developing those systems for the new vehicles, Orion and SpaceX Crew Dragon, Boeing CST-100, Gateway, and now HLS as well. And we can talk about those more later if you'd like to. But what I'll do first is I'll just kind of touch on these behavior traits that I've kind of observed over the years in case it could be of interest. So I'll start with kind of a thought experiment if you'll bear with me, and I'll see if I can present my screen here. How do I do this? Okay. Is that displaying?
Yes, we see it.
Okay, great. I may have to move the video here. Okay, so I remember what I loved about physics when I got started was the simplicity and sort of perfection of the first order calculations that we learned sort of early in the physics curriculum, and this example being sort of how to attain an orbit and then the different types of eccentricities and so on. And then later in physics, learning more about, okay, then how do you add the second order? How do you account for, wind resistance? And how do you add the second and third order and fourth order kind of considerations? And then eventually what absolutely fascinated me and captivated me was then taking that and actually putting it into practice and seeing how the shape that you see you know, from a real launch, it is fundamentally the same shape I learned in, you know, freshman physics, but there's all these other factors, there's all these other second, third, fourth, and fifth even order considerations that you have to take into account. And I use this kind of as a mental model also for a new venture I might be starting, you know, thinking of it almost like as a launch from the launch pad. And as you get started, fire your engines, you get started, things are looking real slow at first. You know, at this pace, just at this point, just not exploding is kind of a plus, you know, and things are looking slow and you're putting a lot of work in, but then you know, your momentum starts to kind of pick up, you start to gain some altitude, you start to kind of get familiar, you find your trajectory, you kind of make some corrections and you pick up more and more experience. And then you got some options, right? You can either do a option A where you kind of come back to Earth and do a suborbital flight, kind of like the early Mercury flights, depending on conditions, or you know, more like an option B or C where you go a little farther and maybe even attain a kind of a stable orbit. In this example, starting a new venture, this would be like sort of attaining expertise in that area. You know, some people have referred to the 10,000 hours of practice it takes to get there. Others have said, well, that's not really 10,000, it's something different. But getting comfortable in an area, getting to where you're fully confident in an area is kind of a way, I think, of attaining an orbit. And then maybe even taking that area somewhere new could be the example E here, where you go off to kind of a new destination entirely. And then at the very point of this pillar of fire here, you know, you've got this vehicle, and I kind of imagine this vehicle as myself in a way. You know, you take that the movie Inside Out and kind of take it up a notch, and you've got, you know, this control panel of different capabilities that you learned over the years, you've picked up from education, from work, from family life, et cetera, and other experiences. And you've kind of got this set of skills that you can turn knobs and dial knobs and do different things, and sort of an almost infinite combination of different settings that you can have of how you approach something. And then you can keep building on this. Every time you have a new experience, you add a new panel of switches and dials here, and you can kind of tune how you approach things. So I sometimes think of things that way. And one way that helps me is during times when it may be tempting to focus on looking out the window at a particular destination, or for a particular, you know, job, or a particular position or title or something like that, and almost thinking about how you control the vehicle to get there as an afterthought. But you can't really do that in orbit. You know, in orbit, if you want to get somewhere, if you're in orbit with something else and you want to approach it, you can't just fire your engines to approach it. You're actually going to raise your orbit and drop back. So you're going to have the opposite effect. So you have to really think about what inputs you want to make to get that desired output of approaching that object in orbit. And it's kind of similar with a career in a sense. So, you know, I found that if you get good enough at flying the vehicle, either remotely or in person, you almost don't have to look out the window. You may be able to optimize to a different set of parameters and get to places you might not have even been able to see out the window. And you can recover from an unusual attitude or a stall. You can get back to a steady climb no matter where you are, just by reference to your instruments and sort of having consistently good habits and practices. So that's one of the biggest things I've learned. You know, this is like a really complex vehicle. This is the space shuttle as an example. And it's hard to see because it's digitized, but every winged vehicle has this core set of instruments. And, you know, there's a scan pattern when you're flying a vehicle. You got to scan these periodically every few seconds to just make sure you're still on track, you're still doing the right thing. And I kind of think of these within myself as well. It's almost like that everything I need to know I learned in kindergarten kind of thing. As long as I can keep these 6 instruments on track, you know, I can tune all these other things and do all this other stuff, but I got to keep these 6 instruments on track and keep myself kind of on track with, you know, my integrity and making sure that I'm doing the things, spending the time in ways that I want to spend it. I'm going to go through these because they're illustrative, you know. So the top center, front and center, most important instrument is the attitude indicator. Attitude, absolutely a key factor in a career. Top left, you got your speed. Top right, you got your altitude. You want to make sure you don't hit the terrain. Bottom left, you got your turn coordinator. Are you trying to change your direction? Are you trying to go somewhere different? And below that, there's a ball that shows if you're coordinated, which means is your vehicle in the right attitude to make that change. Bottom center, where you're headed, what direction you're going. And then bottom right, you got your vertical speed. Are you climbing? Are you falling? So these are all things I kind of use almost thinking of it as a scan pattern within myself as I'm kind of progressing with what I'm doing. So with that as kind of a thought experiment, I'm going to stop sharing here and just talk a little bit about some successful professional behaviors I've observed over the years that I've seen that I think help people succeed in the work environment. It's in no particular order. I'll just go through it here. So one thing is that you're going to have to continuously adapt. So you all have demonstrated already your ability to adapt because of this COVID situation to complete your education and graduate and complete your degree in the virtual environment. Something completely unanticipated. There's no way you could have predicted that. And that's a demonstration of your adaptability. And that is a success criteria. That's something that will carry forward and be useful to you. That ability to handle a totally unanticipated curveball and roll with it and still achieve the mission. That's key. So, and that also comes into play because the landscape will shift under you over time. The needs, of as you progress are going to change. And what got you here, the skills that got you here aren't necessarily going to get you there. There's actually a book called that, What Got You Here Won't Get You There. Great book. And so you're going to need to adapt. So, I mean, what I do on a daily basis now is almost 180 degrees from what I did when I started my career here. So this practice will also keep you vigilant and kind of prevent blind spots from forming. It's good to have that self-awareness. You ever met somebody who seems to be unable to progress to that next level of their potential and they can't figure out why, or maybe they're blaming it on others? They may have a blind spot. You know, so self-awareness is really key. It's really important for your success. So check in with yourself every now and then, make those minor course corrections over time, do that scan pattern, because it may not be possible to do one big course correction all at once when the need arises. So that's one thought I wanted to pass along. If possible, do what you're interested in. You know, there's going to be times where you're hitting a big challenge and you're going to need to dig deep and find that inspiration. And if you're doing what you're interested in, that's going to help a lot. It's going to provide that energy to dig deep and help get you through. When you're figuring out that, you know, whether you want to go to that next position, figure out what the problems that are being solved in that job. You know, the way the job looks or sounds may be different from your actual day-to-day. What are the actual problems you're going to be working on? Every job has problems, challenges, otherwise the job wouldn't exist. The question is just what types of challenges do you enjoy? So that's one way you can think about it. Know what your job is. You know, ask for clarification. What are the boundaries of your job? What are the points? If you're working in a team where your job, you know, has a boundary with another person's job, at what point do you hand the baton over to that other person? Knowing these boundaries will kind of help prevent things from getting dropped between you and others, or also prevent double work or stepping on toes, which can kind of create some conflict as well. So it's just a really good thing, really good practice. One thing I've noticed too is to try to match your confidence in an area to your competence in that area. So, you know, assess your true competence in something and then match your confidence to it, maybe with a half a notch, dial it back for some humility, you know, and keep learning, and that'll push your real competence up, and then just keep matching your confidence with it. Have you ever met somebody who, you know, their confidence is way higher or way lower than their sort of true competence? They're less effective, right? If you're overly apologetic, you're going to be less effective. If you sort of think you know everything, you're also going to be less effective. You may have a blind spot and miss something. So try to match those things and do it again, like my partial differential equation example. Do it, decouple it, do it by area. So, you know, my confidence in myself as a gymnast is very, very low. I'd make a terrible gymnast. I have no skills in that area, and that's okay. That doesn't affect, you know, my confidence in what I do. So those are decoupled for me, and that's fine. And so you just kind of treat each area separately. That's something that's helped me out a lot. And that'll also, it'll propel your growth. That humility and that continuous learning will propel your growth. And it'll also just make people enjoy working with you, you know, so that's another positive thing, and help you build relationships throughout your career, which always ends up being really productive later, especially later in your career. Another thing about the work environment, when you're making an input, you know, an email, or you're making a statement in a meeting, you know, stating your opinion or something, I kind of almost think of it as a vector, and I try to ensure that vector has at least a partial component that points in the direction of the team's goal. Every now and then you'll hear, you're in a meeting or something and you're trying to accomplish something, and somebody will make an input and you're kind of looking around like, okay, what was the point of that? That was totally not productive, right? Try to have each input in some way, be at least partially pointing towards the team's goal. And again, spend a moment thinking about what is the output, what is the result you're hoping to achieve, and what best input would help to achieve that result. And it may be something different than just stating your first opinion. It may be more subtle than that. In a work environment, you can complain about how something is, or you can kind of choose to be a part of fixing it. And the hint is do the latter, right? Just take ownership. Don't complain. Don't just point out issues. Propose solutions. Help to solve them. And try not to waste energy on drama. It's just a complete and utter waste of time. That vector doesn't have any component pointing towards the team's goal. Just redirect that energy. Don't spend it in that area. Redirect it towards the team's goal, and the efficiency gain will be noticeable. Another thing about starting a new role, I recommend picking something small and getting good at it. If you've seen that Geico commercial where there's a whole symphony and there's one guy on the triangle just killing it on the triangle, be the triangle guy. Pick something small, get really good at it, and help start taking the burden of the team. Take ownership and establish kind of credibility and trust, and start sharing the burden of the team or the work of the team, and show your ability and willingness to share that burden, and that'll build your trust with the people you work with. When you're working on solving challenges, there's always going to be differences in approach of ways to do that. Every problem kind of has multiple parameters. One thing I've observed is you kind of want to figure out which parameter you're trying to optimize to. And defining the problem is a big part of it. I hope I'm not misquoting. I think it was Einstein who said that if he had an hour to solve a problem, he'd spend 55 minutes defining it and 5 minutes solving it. I think that stands true. If you can figure out what parameters you're trying to optimize to, then the final solution ends up just kind of popping out. And the same applies when you're operating in an environment, when you're not sure exactly why it works the way it appears to work. Figure out what parameters the environment is optimized to, and that'll help you understand how to engage with that environment in a successful way. Like, for example, I work for the US government. We have a bit of a rep for being inefficient in areas, and maybe some things not making a lot of sense and having a lot of forms and paperwork and stuff like that. We're trying to get better, but that is something that we carry along with us. But over time, you could choose to get frustrated by that, right? But over time, what I learned is efficiency isn't the parameter that the US government is optimized to. It's optimized to the parameter of representation. And that's a value I believe in. That was set up intentionally by the forefathers. And that helps me get comfortable with, okay, occasionally I'm going to see maybe some inefficiency. And that's okay. I'm still going to work to reduce it, but I'm not going to let it get to me kind of on a daily basis. So figuring out what parameters being optimized to will help you successfully engage with your environment. If you're solving a problem with, say, another organization, another stakeholder, and their position doesn't make sense to you, there's a huge temptation to say, well, they just don't know what they're talking about. I strongly encourage you to resist that temptation. It's highly likely that they may either have some information or another viewpoint or another stakeholder of their own that is causing them to have that position on that topic. Seek first to understand before being understood. And that will also build your relationship with them, and it will allow you to see possibly a joint solution that meets their needs and yours, or will help you both prioritize which needs kind of take precedence. But use it as an opportunity to learn, and that'll also build the relationship and make you more effective about implementing some kind of a solution in that area. Again, with challenges, decoupling them from each other and addressing them individually is a good thing. It's very useful from calculations to major projects, major integrated projects, just try to break it down and figure out each piece. Leave some room for humor. It's a great relief valve for a team, almost especially when things get a little bit stressful. So I found that, keep it appropriate, et cetera. Make sure you're not alienating anybody on the team. That's really important. But leave some room for it. It's really healthy. A few last things on professional behaviors, and then I'll move on to a couple of leadership things. so getting good at time management is key. You've already proven that you can do that by graduating from this program. You can't graduate from this program without being good at time management. So you're already there, and keep growing that skill, keep developing it. The way I do things at work and coach folks on how to manage when their plate is full and overflowing, which it always is, and almost will be in every role you're ever in, is keep a list in prioritized order, but put a dotted line on there above which, yeah, you got time to do those things, but below which, that you're not going to have time, at least now, or you're going to have to defer some of that work, and what the risks or the impacts are of doing that. And then make that transparent. Like I show my boss, if there's a list of things and I know I can't do these things, I'll share, okay, here's the priority list I'm working to. Here's the stuff I'm going to do first. Here's the stuff that's either deferred or maybe I recommend we don't do. And allow room for input there. No, switch this priority instead. Do this instead. Okay, good. I'll do that. But still, here's the list, and it's clear to everybody. And that allows for some magic to happen, because now you have other members of the team that they clearly are aware of the things that are not being done, and they can pick that up. It allows for delegation and sharing of workload. If there's a hot spot where there's more work on one person than another, it allows for some shifting of that, and you can break it off into kind of discrete chunks that can be shifted over to another person to execute. So that's very handy. And it's also a stress reliever, because if you know that you have the thumbs up from your boss to not do this work based on that reasonable approach, starting with, that's very relaxing. You're not worried about, oh, God, I'm still not gonna be able to get to these things. And every day you're dragging it along behind you like those mines in the movie Galaxy Quest. You don't want to have that weighing on your shoulders on a daily basis. Let it go, and that allows you to focus, and you'll actually be more efficient at executing the stuff right in front of you if you know that you don't have to worry about this other stuff because you've gone through that process. I recommend that. That's helped me a lot. And that helps with delegation too, which is a really important leadership skill. In general, with career growth and success, try to focus on, I'm assuming you're probably going to be working in teams. I think the vast majority of the work happening these days is in teams. So you'll hear me talk a lot about teams. I recommend focus on your team's success rather than your own, and your career progression will take care of itself. You still have to do certain things. You still want to be ready for that next step. You want to, get mentorship, be a mentor, crystallize your thoughts, get coaching on things like resumes and interviews. It's not a waste of time. It really is important to get that coaching, and it's not because you're trying to sell yourself. It's because you're trying to fully convey your capabilities on paper and in an interview situation. So highly recommend spending some time getting coaching on resumes and interviews. And I could do a whole talk on just that, but I won't go into that today. So be ready to show your capabilities and when you apply for that next step. You can't go to the next step if you don't apply for it. But don't let that be something that's guiding your every action every day. In general, focus on your team's success. How can you help your team get there? And that'll show. It's surprisingly rare, and people will notice, and they'll want to see you succeed because they'll see that your focus is to help others succeed. So yeah, the human element, like I said, it's kind of become more prevalent in my work more recently. It's kind of like surface tension. It doesn't seem like a big deal when, in comparison with other big forces, when all the big pieces are moving around and you're getting started with a project. But once you get on orbit, surface tension, that it kind of becomes more dominant. It can really gum things up, if you don't account for it. So take the human element into account. There is an adage that people won't care how much you know until they know how much you care. That is true. And so, and one of the most useful and least advertised skills for the professional environment is conflict resolution. I don't mean like showing up, with a sword or something like that. I mean, you're always going to have small differences in opinion, and figure out a toolbox for how to work through those with people and can productively have conversations where you show you get what they're trying to say, and here's your thing, and how can we figure out something that kind of meets both. That is an extremely useful tool, one of the most useful in it, and I think it's a little bit underemphasized sometimes. Two last thoughts on the professional environment. One is that there's no such thing as perfection. It doesn't exist. So if you're seeking perfection, you will be frustrated constantly. It's not out there. But excellence is available, and that's what I ask of my team. So you can reach for excellence by simply forming that habit of incremental improvements. For me, it's daily. At the end of the day, every day, I check in with myself. Hey, is there something maybe I could have done a little bit better for tomorrow? If I was in that same situation, how would I maybe just improve that response that I had just a little bit? It's amazing how far that will take you. And you're not beating yourself up or getting down on yourself. You're just saying, hey, look, what's something small I can improve for next time and improve for tomorrow? And the last thought on the professional environment is, it is incredible how effective it can be to simply focus on adding value wherever you're at. Just give more than you get. And that really applies at all career levels. And I still try to do that to this day. So I have a small section on leadership skills and then some other stuff. Is this a good time to open it up for any questions on the professional environment part?
Sure. Does anybody have a question for Paul?
All right, well, what I'll do is jump into the leadership behaviors, and then we can circle back again with any more questions later. Leadership behaviors. So at some point, you're going to find yourself in a position of leadership. You may already be there. Some things I've found that have helped me a lot through the years in a lot of different scenarios. Setting expectations is the top of the list for me. It's so critical. And when there's issues with performance or team interactions or things like that, it's so common that the issue is actually a gap in expectations. Somebody thought they were doing a great job, but they, in your eyes, they weren't. And it's because you were operating to a different set of expectations. So clarifying expectations, and it's never too late to do it. As soon as you notice there might be a gap, go ahead and address it. And don't worry about the lost time and the water under the bridge. Forget it. Just address it now. It's ideally you do it at the beginning, and that's great. But if you don't, catch it later and do it then. But syncing up on what you're expecting and what the other person what are you expecting of me? What am I expecting of you? It's just very, very useful. Have a clear goal. That's key. Set that North Star and make sure everybody can see it. But as far as the path to get there, I'd recommend leaving that more open for the team to identify the best way to fill that path, find that path. And in that vein, when you're talking to the members of the team about gathering inputs on how to approach something, there's some things that you may be able to give the team a vote on and some things you may not be able to. Like if your boss tells you, okay, the organization is changing in this way, lead the team and help them get to this new organizational structure. The communication with the team becomes something like, well, okay, so here's what's not optional, right? We're doing this, but here's what is optional. I'd like to get your take on, how we might get there. And that part is flexible. So seek those inputs and doesn't mean you incorporate every input you get, but seek them and respond to each one. But what you don't want to do is incorporate inputs when you don't have the ability to, or seek inputs when you don't have the ability to incorporate any of them. It's very demoralizing for the team. They put a lot of thought into it. They send you the input and then you say, thanks, but we're not doing that because we don't have that option. So making that clear of what's optional, what's not actually can be a really helpful thing too. Being optimistic is really, really important. It's very hard to follow a pessimistic leader. You got to believe in what you're doing. If you don't believe in part of it, maybe refocus your efforts on the part of it you do believe in and just have that be your focus area. But whatever your focus area is, you got to believe in it. Otherwise, you're not going to be able to lead people. It doesn't mean you're being naive. It doesn't mean you're saying everything's going to work out. You could say we might not make it. But it doesn't mean you're not being optimistic. Optimism is talking about solutions, possible solutions. When things are difficult or uncertain, face facts and don't blow smoke, but think and talk in terms of possible solutions, not what could just go wrong. And the other thing is being willing to start towards a solution before you see the end. You may not see the end as you get started, but try to unlearn any habits around cynicism and sarcasm, because they'll just eat away at that progress and make it harder for your team to be effective. Speaking of the team, so building others up is key. Everybody wants to be valued. That's just human nature, right? So you got to somehow show each person on the team that they're valued. And you may have quieter members of the team who may be less inclined to speak up and provide their input. They may have the best idea in the world and they're just not sure of it and they just don't really want to say it, you may have to kind of provide them their own stage for a moment and encourage them to bring it out. And then you may have others on the team who are quite more than happy to tell you their opinion every minute of the day, and maybe you have to even kind of filter that down to some appropriate signal to noise ratio. But value everybody and show them that. You know, and here's something that may be really obvious, but I've seen enough people who don't do it that I'm going to say it. Learn everyone's names. It may be a big team and this may seem hard. Do it. It is critical. That is the first step towards showing that you value somebody. So expectations, you know, we talked about it. So set them high, but provide support. Make sure you're setting high expectations. People want to be a part of a winning team, but not impossibly high, right? And then provide that support so they can get there. So provide them a path to get there. And they'll be able to achieve things that even they thought they couldn't do. If you set it right, you know, don't set it too distant, you know, set it right. So that's something I've seen over the years. You have to be a good follower to be a good leader. You have to be willing to do the things that you're asking others to do. That's a thing. Taking care of yourself is a thing. You know, if you're showing up to work, a team's like, hey, what's up, boss? And you're showing up and you're visibly stressed and frazzled and exhausted. That's not a good look. You know, it's not a good sign. And people look at each other and think, am I really part of a winning team? If the leader's kind of freaking out about our situation here, do I need to be jumping ship here? You know, so your comportment is representative of the team's comportment. So set a good example in that area. And again, it's not about blowing smoke or putting a smile on your face when you don't feel that way. Be real, but you know, be optimistic and take care of yourself. Get enough sleep. If you're sick, take a break. You know, that's important. Focus on the people, focus on recruiting, spend a lot of time on that, retaining people, making sure they know they're valued. Having a smaller number of the right people is more important than having a big team of people who maybe not best suited to that work. Let's see, feedback. Don't shy away from giving feedback. I know it's a really hard area. It was hard for me to get used to giving real feedback to people. But people, they need it. They you know, if you just say something like, well, everything's fine, don't worry about it. And then, you know, behind their back, you're saying, well, I wish they would do this, that, or the other. So you're being kind of dishonest with them, and it's kind of demoralizing for them too, right? Versus just hearing from you. No, here's an area where, frankly, you know, you didn't do very well, but here's the challenge for you. So let's see if we can improve in this area. And it's not about focusing on the negatives. It's about, let me challenge you to grow in this area. And people will take that and they'll appreciate that feedback, that real feedback. It's refreshing, and not everybody does it. Let's see, give the team some space to vent and connect with each other without you there, even if it's some of it's about you. The dang boss. That up to a point, that's actually kind of healthy for the team. It helps them kind of gel together. There's some common thing for them to vent about and connect about. And a close team is a high performing team. So give them some space for that. And then if you're going into a new leadership role, I go in assuming about half the people on the team are probably going to think they could do the job better than me. And I may have to earn some trust there. So, you know, then if you go in assuming that, you won't be disappointed when you're working with folks who may take a little bit of time to warm up to you. Work to earn their trust. You know, show that you have their best interests at heart, show that you value them, and that'll come naturally over time. There's a whole section I could talk about what's management versus what's leadership. Bottom line, you need both, and we can get more into the Q&A if you want to talk about management versus leadership. Last thing, have candy and tissues in your office. That's the last thing I have on leadership. So I've been talking for a while. I want to give just kind of a summary thought here, and then I have some other stuff I can add if you want to talk about an example from mission control, or if you want to talk a little bit about how NASA is structured, or what the human spaceflight programs are and what's happening with those. We can talk about that. So what I'll do is I'll do this kind of summary slide, and then I'll open it up for whatever is of most interest, and kind of depending on how much time we have left. So let's see if I can get this to share. Is this sharing currently? Are you all seeing this image of the stars?
Not yet.
Okay. Let me see if I can. Oh, here we go. I'm not actually sharing yet. All right.
Now we see it.
Is that shown? Okay. You see the
Yes.
image of the stars?
Yep.
Okay. So I just want to kind of end on this image. This isn't any one particular area of the sky. This is just looking up as the theme here. So, you know, it's safe to say this image kind of inspires each one of us in our own way differently. You know, some may see stars and galaxies, some may see constellations, some may see the ability to look back in time. Some may see spectra, dark matter, dark energy, black holes, other things not visible to the naked eye. Some may see potential destinations. For some, that reminds them of faith or of our place in the universe, obviously the center. For some, it reminds them of others in different places or in different times who could look up and see the same thing. You know, some might see the current COVID-19 situation as kind of a dark time, but like this kind of dark image, you know, the closer you look, the more you find. So whatever it is about this image that's inspiring to you, my last message to you today is keep that wonder. I do to this day, and it fuels me. And this can be a great way to reset with somebody if you're working with somebody on a project and you need to kind of come back to basics and have a shared set of values. We have one in mission control called the Foundations of Mission Operations, which we can talk about if you want. But it doesn't have to look like that. It could, whatever it is for you or for the team you're working with, whatever that shared set of values is, have that to keep coming back to, and that'll really help. So in summary, the three things I wanted to emphasize today: keep the wonder, tap into it when you need more fuel, set up that scan pattern for your attitude indicator and your other core instruments as you're kind of flying through your career. Get a little bit better every day, and then wherever you are, try to give more than you get. If it's energy, time, give it to institutions, give it to people. Even if it doesn't come back to you, it will still energize you, and also it will come back to you. So that's it. I'll open it up to any questions.
Great. Thanks, Paul, for an inspiring talk. I'm wondering how my career would have gone if I had heard it 30 years ago. But let's open up for questions. Does anybody have a question for Paul? You can either unmute yourself or type it in the chat window, whichever is easier for you.
Can I ask a question? This
Sure.
is Nadia. I'm not actually a graduate, or at least not a current one. But I have a question about nonlinearity of careers. And I see this tendency, especially amongst very ambitious and very hardworking and very determined individuals, to not have the ability to keep failures and losses in perspective. People are terrified that losing an 0.1, points of their GPA is a disaster. People are extremely stressed out about each individual exam, thinking that it spells doom and gloom for their careers. And the environment at many institutions is such that, this kind of thinking is not discouraged, but encouraged by, certain institutional elements. It's very hard to get away from this perfectionist attitude. And I'm wondering what your experience has been with nonlinearity of careers, people circling around, coming back, advancing, your experience, how people, can people be very successful after backtracking a number of times? Can you give us all reassurance that, these setbacks that students especially sometimes perceive as very dramatic are not actually dramatic, or maybe you have a different vision of this problem?
Yeah, I mean, that's such a great question. So I'll tell you, when we're hiring somebody, if they show up and if they have a 4.0, my first question for them is, can you fail? And what I mean by that is I'm looking for people who can overcome adversity. I don't honestly really care what the final number was, as long as it was above some certain, level of expertise or effort at least. But that what I'm looking for is that tendency to try again and get back on the horse and persevere, right? That's way more important than any sort of absolute value number of a GPA or something like that. So, and then the other thing I look for is a wide variety of, throughout the team at least, a wide variety of experiences. I'm not looking for somebody who's flighty and can't stick to something and has 30 different experiences because they left each one after a month. That's not what I'm talking about. But get a variety and stick with at least a few of them. It may have to be in parallel. But what I'm looking for, for my team, I'm not looking for a monolithic group of people who are all exactly the same. We have the kind of more of a Moneyball approach, the baseball team approach, where you got one who's a good runner, one who's a good batter, one who's a good pitcher, and you put them all together and they make a great team. So sometimes what I'm looking for is somebody who's bringing in experiences and sort of free benchmarking, if you will, from an area of industry or the military or somewhere else that we don't have anybody on the team who has that experience yet, and they can share that with us and help us learn from that and grow and develop from that. So I see it as a strength.
So another question for Paul? So I have a question, Paul. Besides learning how to solve PDEs from John Bagger, what would you say was the most valuable, or what were the most valuable skills or experiences you acquired during your time as a physics student that still are valuable to you today?
I think it really was the working with teams, taking personal ownership for my own knowledge growth, but coordinating within a team on projects and working on projects and sharing, trying out different methods. Every group of students ever assigned to a team project has always started with well, let's not pick a lead because nobody wants to be like the one who's saying I'm the lead, so we'll just do this kind of flat organization. And that's always something that everybody tries. I tried it, doesn't work. Just in my opinion, you just need somebody who's kind of the point of contact, if you will. But those kind of things, those kind of lesson learned, working with people, and also just and just making friends and kind of having some sense of joy coming out of it in terms of you're actually sharing friendships in addition to learning and growing and developing. So it's not all just like nose to the grindstone kind of thing. There's some enjoyment coming out of it as well. Taking joy in the work.
Great. Another question for Paul?
So if you want, I can do the Tales from the Trenches. It's a situation I was in Mission Control. It was a bit of a hairy one. It's an audio clip with a visual that goes along with it, and it's about 3.5 minutes. So if we have time, I can take
Sure.
that.
Let's see it, Paul.
Okay.
Absolutely.
So bear with me as I try to work out the tech here. I'm gonna see if I can share the audio in addition to the. So let me do this. So is this image showing?
Yeah, we see you in front of some monitors.
Okay, so this is Mission Control. So this is me at my console in Mission Control many years ago. And I ran into a situation. It was on February 11th, 2008. I'm gonna bring up an audio if I can get it working here. Sorry for my tech issues. Here's what I'm going to do. I'm going to try to. Here we go.
Okay, next up, Cole LTL.
Are you all able to hear that video or that audio? How's the volume, up or down?
Sounds okay to me. Yeah, good.
Okay. we'll go back to the visual. Okay, so I'll set this up. So what we were doing, okay, can you now see the image of the space shuttle dock to the space station? Okay, so what we were doing, I'll set this up real quick before I start the audio. We were installing this module here, this on the right, this Columbus module. It was built by the European Space Agency. We were installing it to the front of the space station. It had come up in the payload bay of the space shuttle, and we'd used a robotic arm to remove it from there and connect it to the space station. And we had crew members who were out in EMUs. That's an extravehicular mobility unit. It's a spacesuit, and they were doing a spacewalk, an EVA, to connect up some of the electrical connections and some of the fluid connections, because we use liquid cooling for the avionics in these modules. They build up heat, and you got to remove the heat. So we have water cooling systems inside that go through heat exchangers to an external system that can't use water because of the temperature. So we use ammonia for that one as a coolant, and then that flows it to some very long radiators. We have 6 80-foot long radiators that I'll show you later. But anyway, we're connecting up the fluid systems. I was the flight controller on console for thermal systems in charge of this part of the operation. We're activating the module for the first time. And as we opened up some valves to connect the heat exchanger, we ran into a serious issue. So I'll play the audio. It's 3.5 minutes, bear with me. And then I'll see if you have any questions. So the main voice you hear when you hear Flight Thor, that's me talking. And we can talk about who the other players are while this is playing here. So I'll get this going here.
Okay, next up, Cole LTL, ISOL valve, open, enable.
And ready.
You have to go.
Receivers handover. Seeker FM6 order blinking into Columbus. LTL FHX. Isolation valve open. Enable command on my mark.
Here you go.
3, 2, 1, mark.
History. Accept.
Now place the open, confirm, and ready.
Flight Thor, have the crew stand off. We'll take a look. This is unexpected. No action for the crew. We're looking at it.
Alpha Houston, Space to Ground 1 on the big loop. No crew action this time. We're taking a look at it.
It looks like it's real.
And folks, it looks like a thermal transient took down ETCS loop alpha. Let me get you a warning procedure we're going to start in.
Looks like Connection's got a thermal. Does this affect the water dump? Should we?
Not immediately.
Okay.
TCON Thor, let's get into the procedure.
Concur.
Here, it looks like a thermal transient took it down.
Yeah.
And Houston Alpha on 50, take in, please.
Yes, Peggy, we
No
see
correct.
warning.
No clue. Big loop.
Thanks.
And TCON, please confirm the PM outlet temp low. Procedure we want is 2.816 for contingency restart. Just check 4469. Make sure the procedure called out is correct. And TCON, I've confirmed it. Flight Thor, go. We're starting in 2.816 in the warning book. It's ETCS contingency restart. It does look as though a thermal transient result related to the integration of the Columbus MTL IFHX has triggered a low temp fitter on the loop alpha.
2.816 you said?
Correct.
And I'm sorry, what do you think caused the transient?
We just integrated Columbus MTL IFHX for the procedure.
Okay.
And keep in mind for Columbus, MTL is on loop alpha.
Okay.
The whole team.
So as we integrated it, the temperature was lower than we expected and it triggered the fitter?
Actually, it looks like the temperature increased quickly, and then the FCV tried to correct. It corrected too far. The temperature then dropped, triggering the under temp. So I believe we can start up the loop nominally at this point.
Okay, and then you said it was a transient, so you think once we start it up, it'll be able to see the right temperature
I
and
believe
control
so.
the FCV?
I believe so, yes.
Okay.
You have a go to begin 2.8 optics.
Yeah, I was just going to say,
Any reason that Falcon and AGCO should hold off on their activities?
airlock if you could stand by.
Not at this point for Thorpe, from Thorpe's perspective. Okay, so no reason to hold off and prep for the water dump, and any reason for the Columbus folks to hold off on their activation? I can't continue to support step 3.1 and Columbus final activation until I've recovered from this, so they can decide if they need that. I think they will. They need your support, you mean? Correct. I have not yet integrated the alpha checks. Okay, you have a go to press forward. Copy.
Okay, so that was the end of that recording. So we record everything we say in the control center so we can go back and listen to it and make sure, you know, hey, look, did we do the right thing? Is there something we could do better next time? It's also a congressional record in the event there's an accident, God forbid. So that's how we get these recordings available to us. So so what was happening there was me communicating, okay, here's the problem. I didn't see it coming, right? So I didn't, it kind of caught me off guard. Here's the problem. Here's what I know so far. Here's what I need to know. Here's a procedure where we've written just in case something like this happens. We're going to get going with it and see if we can troubleshoot and figure out what happened here. So, and then in the background, you hear the crew calling from the space station because they had the alarms on board asking, hey, you know, do you need us to do anything with these alarms? And the Capcom said, no, you know, we'll take care of it with commanding from the ground here. And then you heard the shuttle flight control team calling and saying, hey, wait a second, do we need to pause what we're doing? And then you had the European Space Agency folks, they had a control center out there near Munich, and they were getting ready to activate their module, and we had to put them on hold until I was able to finish this troubleshooting and then get everybody going again. So high pressure, high stress situation, but when you get the right training, you just follow the training, right? And just go back to what you learned. And and that was like 4.5 years after graduation. So you just never know the situation you're going to be put in. So just do your best, get prepared, learn everything you can, and be confident in yourself and your abilities.
That's great, Paul. Thanks. So any final questions for Paul? Well, thanks. That was really very interesting, Paul. Fascinating talk, and fascinating view of how things work in spaceflight. So I think we're coming to the end of this virtual gathering. I actually have one slide I was hoping to share. Can I just share it directly, or do I need permission here? Okay. So Paul, if you stop sharing, great, thanks. Typically in the in-person ceremony, or reception, we would call each of you individually up one by one. That seemed, of course, both impossible and kind of tedious to do over Zoom. So Kelly and I instead just scoured the internet for photos of all of you, so that we could display it all and wish you all at once all the best. So maybe I think we spelled Catherine's name wrong. That's a great thing about PowerPoint. I can fix that on the fly here. I don't have my glasses on. There we go. So well done to all of the graduates. Catherine, Sinesh, Kevin, Sydney, Henru, Jason, Shannon, Serena, Christian, Andrew, Sasha, Nina, Carolyn, Will, Serena already said, Travis, Daniel, Michael, Margaret, and John. We're all very proud of you, and we wish you all the best for a wonderful future. I think I'll stop sharing. So I think some of us may stay online if people like to chat informally. Paul, if you have a few minutes to stay, that would be great. Otherwise, I think this ends the formal aspects of the virtual reception. I hope everybody has fun tomorrow as best you can with the virtual commencement, and we look forward to hopefully someday seeing everybody, passing through Bloomberg once again. Congratulations.
Congrats.
Thank you. Congratulations.
So Paul, you said that audio came from 2008. Is that right?
Yeah, that's right.
So that's just 5 years after you graduated college. So you were, I mean, that seems like you handling things, like that at such a young age. Is that unusual?
That's basically the focus area for that job. So as soon as you show up on day one, you're getting started with learning how to do that stuff. And so a few years in, yeah, you're ready. So there's a certification process. It takes a couple of years. Took, I think 2 years for me and they test you on it. They have a computer model that kind of simulates stuff like that. And they can, if you ever seen the movie Apollo 13, where the crews, they're kind of practicing the docking, and they say, well, the instructors are in the background saying, well, let's see what he does with this. And they put in a malfunction, in the model, and have the computer kind of shift to the left, and, oh, look what happened. We got a malfunction. It's pretty much like that. It's just a newer version of that with the computer screens that look a lot like the ones in the control center. So you get used to it after a couple of years.
Did they do much? Sorry.
What would you say your research at Hopkins prepared you for working at NASA?
I think it was the knowing how hard you have to try sometimes. So when I paint this picture of, believe in yourself, be confident, I'm not saying bluster. I'm saying you have to work hard, and then you can believe in what you've done because you've worked hard to earn it, right? But yeah, and so that's what Hopkins taught me, is I had to work really hard. I wasn't joking about the overnighters in Puck Lab, and they were plural. So, that's, I think that just knowing, having that example of having to dig deep a few times and realizing I was capable of it, in surges, not all the time, but in surges, that was a big thing. And I did use that actually at work sometimes.
Yeah, that's certainly what I often tell students. I say, at every university, there's that one major that is the really we used to call it, when I was in college, the gut major, a really easy major. I think the students maybe correct me, but my understanding that economics actually at Hopkins has that reputation. When I went to college, it was psychology, and but nowhere on no campus in the world is physics the gut major, right? Everybody who you graduate with a physics degree, everyone in the real world recognizes that shows you're good, you have strong analytic skills, and you're not afraid of work, which is those are two good skills to have.
Yeah, there's lots of industries that are interested in people who work hard.
Oh, wait, one more thing. I think there's some students. There's one thing I meant to mention. Those of you who are still, those of you who are graduating, who are still in the meeting, if you haven't already done so, please send Kelly your T-shirt size. So, this is in lieu of an in-person graduation, you're going to get a T-shirt. And Paul, please send Kelly your T-shirt size too. You're now an honorary member of the class of 2020.
That's fantastic. Thank you.
In terms of the discussion that was just being held, I was interviewed long ago for Ohio, or one of the oil companies, and I asked why they were interviewing physicists, particularly a theoretical physicist. And what I was told is that when they wanted someone to hire someone who knew how to operate the standard equipment that they had in the field, they hired a geologist. And if they hired someone that was going to think about why they were using that equipment and how to make it better, they hired a physicist. So I thought that was an interesting, they weren't looking for the expertise, but the ability to think.
Yeah, that's so good to see you again, by the way, Professor Robbins. And that's one thing I noticed as well when I arrived at work for the first time was I was all about the why. And at a certain point for operations, again, this is not engineering, it's operations. You take the vehicle the way it's designed and you fly it the way it was built. You don't really ask, you can ask questions about how it works, but you're not going to be able to change the design really at this point. It's already in space and so on. So I had to kind of unlearn the asking why thing. And at some point I just had to accept, okay, this is the way the vehicle's designed. I'm just going to stop asking why and focus on, all right, how can I? But then later with the vehicle development for new vehicles, it then came back in again.
Yeah, it's great to see you again too. It's great to see how well you've done.
Thanks. It's very much a testament to Hopkins, and so proud to be a part of this this organization.
So Paul, do you remember any of your other people the teachers you had when you were here?
Yeah. So, you know, definitely have memories of working with Dr. Bagger. Of course, you several here on the call here.
Was it 201? Was I teach? Remember, was it the Waves course?
It was the.
Or was it
Waves? I did
you took
Professor Reich, I think. I did solid state with you.
Yeah, that's right. That's right.
Yeah. And Broholm, I remember. And Adam Falk was my undergraduate advisor, and then working with Professor Feldman as well. He was the chair, I think, at the time, and planning the SPS trips and working with him, and of course Pam Carmen on those. Working with Professor Henry on the Space Grant Consortium work. I remember worked with Professor Saleh as well. So yeah.
Cool.
Yeah, it's funny. I was at a work gathering the other day, and we had some lemonade that had been made that was too weak, and people were complaining about the lemonade. It was too weak, and I told them, you know, shared suffering really has a way of bringing people together. So I enjoy that, and that was my experience a little bit with with the physics program as well.
Yeah. Certainly, you make good friends that way. That's for sure. Yeah.
That's right. Yeah.
This is Dan. Yes, I mostly had taught the beginning courses for the undergraduates. I think with Paul it was Physics 201, and with some of the people, well, many of the students here, it was Physics 105. And it's amazing to see you, Paul. You know, I can still remember you from that, you know, what you were like as a sophomore in 201 and 202. And, you know, but even for the students who were freshmen with me a few years ago in 105, you know, you all have grown an enormous amount, and it's just been, you know, amazing to watch that. So these, this juxtaposition of my memories of Paul and all that he's done have been really wonderful. And I'm expecting that to happen with this crop as well in the not too distant future.
Yeah, it's the same for me, and I hope to be in touch more than once every 17 years from here on out.
That sounds great.
I was just curious. I remember you worked on the Vomit Comet, didn't you?
That's right. Yeah, we did a joint thing with the mechanical engineering department, and me and Paul Nurnberg worked with some of the folks over there, and came down to JSC, and we actually worked. I mentioned working in the machine shop at the basement of Bloomberg. That's for real. We did that. We built it there. We built the pieces there, and put it all together over at the Mech East side. And we had some surface tension mixing experiment we were doing. It ended up being the surface tension forces ended up being overpowered by the vibes on the plane for the most part. So we didn't really get any conclusive scientific results, but I did learn a lot about how to approach gathering data like that.
And what's Paul Nuremberg up to these days? Do you know?
I want to say is he at Caltech these days?
Oh.
I know he's a professor out there in Southern California. He's been doing great work.
Oh, very good.
Do you remember he was specializing in I want to say he was specializing in the intersection between physics and kind of microbiology, if I remember correctly.
Okay, cool.
Okay.
Was Heather Knutson in your class?
Yes, yeah, she was. Yeah,
she's also at Caltech now.
That's right. Yeah.
Yeah.
She and Paul are married.
Oh.
And have kids. Have kids.
Okay,
Yeah.
so this is you can get a lot out of a Hopkins education. Those of you who still on the...
exactly. That's right. Yeah.
I did not know that.
Wife,
okay.
I met my wife at a Goddard internship the year after. Yeah, a few months after graduating from Hopkins. Yeah.
Cool.
So I didn't want to kind of completely dominate the conversation. I wanted to leave room in case any of the graduates wanted to speak or have questions, but I am so curious, just how things are going with the department, any news there, and, do we still have the big telescope on the roof and any other things coming in the future here for the department?
Well, yeah, the telescope is still there, and I think there's still it's open each Friday evening for the public to come in and make observations. We have you must have taken the advanced lab course, right, back in the day, as a junior probably.
Yeah, I think so. Although I think the telescope that was a separate.
So that tells. But the reason I brought that up is it's not as grand looking, but there's actually a second telescope now on the roof, which is a radio telescope that's used to measure the velocity profile of the in the galaxy, basically. As one of the labs in the advanced labs, so students are using to this day telescopes on the roof.
Very cool.
Yeah. So, and yeah, not too much has changed in the building looks probably very similar to your back in your day. I mean, the carpet's a little older, but and worn, but otherwise it's not no big changes in the infrastructure. I mean, there's been quite a bit of building on campus. I mean, since you were around, particularly at the other end of campus, the south end, near the engineering school. I mean, they've built several buildings, and there used to be a big parking lot, I think, kind of behind the mechanical engineering building.
Oh yeah, yep.
Next to Garland.
Next to Garland. So that's now, that parking lot was put underground. It's a garage now.
Oh, okay.
And so that's a big grass quad, and there are a couple of new buildings around it. So they've upgraded that end of campus quite a bit.
Huh.
And taken over Wyman. The Wyman Park Hospital is now where the deans sit, and
so the campus has sort of grown in that direction as best it can. So in engineering, was it Celia Herman you worked with? Was she the one who was doing the research?
That's
right,
correct.
Okay.
Yeah, and I don't know if she's still there.
I think she's retired. Mark, do you know?
Okay.
I think so.
Yeah.
It looks like Professor Short's dropped off. I was just gonna mention, I still have my old copy of a senior thesis I actually started with him that unfortunately I never actually finished.
Oh.
I have it in my file. I'll have to dust that off. It's numeric integration of the hadronic contribution to the electromagnetic coupling constant. So I'll have to dust that off and see if I still got it.
Yeah, well, I don't know. You may have gotten credit for that, Paul. Are you sure you really graduated?
Yeah, that's actually a really good point. Yeah. I'll have to go back and double check that.
Yeah, she's emeritus now. I just checked.
She's emeritus. Okay.
I'm going to drop off, so I'll just say to Sydney and Caroline, you're still on the call. Congratulations to you both. I wish you all the best for the future. It's been great to have you in the department. Paul, it was wonderful to see you again, and we really appreciate your taking the time.
Thank you for everything. Yeah. Very good to see you again.
Thank you so much, Professor Reich. It's great.
All right.
Yes, congrats to the current grads.
I want to say it's great to see everyone too, and thank you so much. I'm gonna leave as well, but
Sure. Good to see you, Sydney. Good. All the best. Best of luck.
all the best. Bye.
Take care. Congrats.
So Paul, do you still act as a mentor to undergraduates? Is that through engineering or through us or through?
I've been actually, so among other things on campus, I was in the fraternity, one of the fraternities, Phi Kappa Psi, and so they reach out to me occasionally and assign a mentor, somebody if they have somebody who's interested in sort of STEM type career fields. But I haven't formally done so for the department. Happy to do it. I love doing it. It's one of my favorite things to do is work with people on helping them achieve their full potential. I really enjoy that part of my work. So yeah, actually, in that vein, if you want to sort of put that out there or make that available, if anybody's interested in space, just not everybody might be going in that direction for their career, but if you happen to have somebody who is interested in that direction in their career, I'd be more than happy to talk with them. I have actually mentored and talked with one or two folks from Hopkins, one of whom actually came down and worked here, Ryan Johnston. But I don't think he was physics. I think he was engineering.
Was he mechanical or maybe?
He must have been, yeah. He must have been mechanical.
Because for some reason I was talking to an undergrad and the fact that you were their mentor came up, and that's. But I
wonder if that was. Could that have been Devin by any chance? Devin Williams.
Devin Williams. Yeah, he's a physics major actually.
Yeah.
Yeah. So yeah, I had a nice long conversation with Devin. I was actually on an interview panel for something he applied to down here at JSC. And after the results came out, I reached out to him and said, hey, let's talk, because I wanted to make sure I passed along to him like the differences in the centers, because there was some stuff that he was talking about in his interview that I thought might be better suited for Goddard. So I wanted to make sure that he knew, okay, like there's different, focus areas and here's what they are. And so he and I talked for like a good hour. Yeah, sharp guy, incredibly sharp. Great crop of students you guys got.
Yeah, Devin's been doing work at APL actually, advanced applied physics lab rather, most recently in quantum computing, which I think is going very well. So
yeah, cool. Yeah, it sounded pretty neat. It also sounded like he was so far along with it that I'm not sure even his advisors there were 100% aware of everything he was developing there. It sounded like he was like literally the one person in humanity who knows as much about that specific focus topic as we know. So pretty cool stuff.
That's cool.
But yeah, please do put it out there if you hear of anybody who's interested in NASA or space in general. I'm more and more than happy to talk with them, or even just resumes and interviews. I've done mentored and coached many people on that, and have lots of thoughts to share. They would have been too boring for a talk like this, but I've got a lot of stuff to talk about for anybody who's interested.
Yeah, that'd be great. Thanks. I mean, that's
yeah.
Yeah.
Well, thanks for organizing this. Thank you, Kelly.